devolve into a mess because everyone has their own convention. So this is a convention to which you should indeed adhere. And then I've indented 4 spaces to make clear logically that this line of code only executes if the answer to this question is true. True or yes. Meanwhile, in Scratch, if we had an if-else condition, so a two-way fork in the road, if x is less than y, say so, else say x is not less than y. How can I do that in C? Well, if x less than y, something, else something else. And what are what goes in between those curly braces? Well, just 2 different printfs, x is less than y or x is not less than y. The only new thing here is we've added else and another pair of curly braces, just like we've got sort of 2 orange shapes hugging those 2 purple puzzle pieces there. All right, how about something a little more involved? And this looks like it's escalating quickly, but it's just because the Scratch puzzle pieces are so big. If x is less than y, then say x is less than y. Else if x is greater than y, then say x is greater than y. Else if x equals y, then say x is equal to y. How can we do this in C? Almost the same idea. If x less than y, else if x greater than y, else if x equals y. Well, before we reveal what's in the curly braces, this is not a typo. Why have I presumably done this, even if you've never used C before? Yeah? Exactly. The single equal sign, which we've used already, when storing a value from getString into a variable like answer, is technically the assignment operator. So humans decades ago decided that when faced with a situation where they wanted to copy from the right to the left a return value into a variable, it made sort of visual sense to use an equal sign, because you want those 2 things ultimately to be equal, even though you kind of read the code from right to left in that case. I can only imagine at some point the same people were in the room and they were coming up with the syntax for conditionals and like, oh shoot, we've already used equals for assignment. What do we now use for equality? And the solution in C, as well as in many other languages, is literally this. They use 2. So this is the equality operator, whereas a single one is the assignment operator. And it's just because. Now Scratch is designed for kids. No sense in confusing little kids with equal signs. So Scratch uses a single equal sign, whereas C and most languages use double equal signs. So a minor divergence there. What goes in the curly braces? Nothing all that interesting, just a bunch more printfs. But here's an opportunity to distinguish not only the equivalence of this Scratch code with C code, but a misdesign opportunity that we sort of tripped over, if briefly, last week. This is arguably not well designed, even though it is correct. Why? Yeah. Yeah, we don't need to ask this third Boolean expression. Is x equal to y, so to speak? Well, logically, if we're using sort of normal person numbers, it's either less than or greater than or by default equal to. So you're just wasting the computer's time and in turn the user's time by asking this third question. So slightly better here would be get rid of the else if, just have a default case, an else block, so to speak, that looks like this. If it stands to reason that there's only 3 possibilities, you only really need to interrogate 2 of them out of the 3. So a minor optimization, but you can imagine doing that again and again and again in your code. You don't want to be wasting the computer or the user's time if you can improve things like that. All right, so now that we have these equivalences between Scratch code and C code for these conditionals, well, what other things can we throw into the mix? Well, C has a whole bunch of operators. And just so that you've seen a list in one place, you've got not only assignment and less than and greater than and equality, but a few others here as well. Now, even though in like Microsoft Word and Google Docs, you can kind of do a greater than or equal to sign one over the other, or less than or equal to, in C, in most languages, you actually just hit the keyboard twice. You do the less than and an equal sign, or you do a greater than and an equal sign. And that's how you achieve the notion of greater than or equal to, or less than or equal to. This one we've seen. Anyone want to guess what exclamation point equals means? Otherwise pronounced bang equals? Yeah. Not equal. So generally in programming, you'll see an exclamation point implying the negation of something else, the opposite. So you don't want it to be equal to, you want it to be not equal to. Now you might think, shouldn't it be not equal equal? Well, yes, but they're trying to save keystrokes. So this is the negation of that, even though it doesn't quite look like it should be. Just 2 characters instead of 3. Dot, 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 there's many other operators that won't counter in the wild over time. But there's also worth noting in C, more than just strings. Like strings, recall, were strings of text, and there's other types of data that you might get from a user or store. We've seen string, but we'll actually see a whole bunch of others. So in C, we're going to see bools themselves, a variable that can be true or false, and that's it. So very much interrelated with Boolean expressions. A variable itself can be true or false. We're going to see chars or characters. So not strings of text, like multiple letters and words and the like, but just individual characters. C, unlike some languages, does distinguish between single characters and multiple characters. Double, or rather, let's jump to float. A float is otherwise known as a floating point value, which is just a number that has a decimal point in it, a real number, if you will. But a float generally uses, nowadays, 32 bits total to represent those numbers. The catch with that is that how many total values can you represent with 32 bits, roughly, per last week? It's one of the few numbers I propose you remember. It's like roughly 4 billion. But how many real numbers are there in the world according to math class? An infinite number. So we seem to have a mismatch between what we can represent in code and how many actual numbers there are in the world. Okay, so not to worry. If you need more precision, like more significant digits, well, you can upgrade your variable, so to speak, from a float to a double, which uses 64 bits, which is a nice command. So you can go all the way to negative 2 billion. So that's not that large nowadays. A long uses 64 bits, which is a much bigger range of values, but there too, still finite. And there's a bunch of others as well. So these are just the types of data that we can store and manipulate in our programs. But a couple of those know A couple of those, one in particular, specifically come from CS50.h. So among the things you get by including CS50.bit, whereby you can get integers or chars or doubles or floats, we don't have a get bool because it's not really useful to just get a true or false value to access. Turns out there's more than just %s. So %s was a placeholder for a string, but if you want to print out something like a char, a single character, you're actually going to use %c. If you want to print out a floating point value, you're going to use %f, an integer, %i, and a long integer that is a long, you're going to use %li instead. So in short,
I just left my home, chat. Glory Island. We started off in Glory Island of Senegal. Now we're about to take a quick boat trip into the city, which is like the city is the city. Like, it's like every other city. So, but yeah, Chad, this is where.
CEO of the car.
Huh? There's got a big. Chad, million. There, y'all. We're about to dunk off.
Short, there's solutions to all of these problems. These are not intellectually interesting details, but they are useful, practical things to eventually absorb over time. So let's go ahead and do this. Let's do just a few more examples together. In a little bit, we'll join for a short break during which snacks will be served every week out in the transit. But before we get to that, let's focus on these here variables. So in Scratch, we had the ability to store a bunch of values in variables that we could create ourselves by creating new puzzle pieces. In C, you can essentially achieve the same. So for instance, suppose that in Scratch, we wanted to keep track of someone's score using a counter. Well, we might create a variable called counter and set it initially to 0, and then eventually add 1 to it, add 2 to it, and so forth as they drop trash into the trash can, for instance. Well, in C, you're going to do something almost the same. You can choose the name of your variable, just like I did previously with answer. You can assign it a value, like 0 initially, but per earlier, what more am I probably going to have to do in C on the right-hand side here? Yeah. I got to give it a type, and a counter, insofar as it's numeric, is not going to be a string of text, and I don't think I need to worry about decimal points if I'm just counting the equivalent on my fingers, so int will suffice. And int is the go-to number, and at least if 2 billion plus values is more than enough for your case, which is going to be. Still one minor thing missing? The semicolon to finish the thought. So that on the right is the equivalent to doing this here on the left. Suppose that in Scratch you wanted to increment the counter and add 1 to the score, add 2 to the score, and so forth. It might look like this. Change counter by 1, implicitly going up, unless you did negative, which would go down. In C, you can do this actually in a few ways. And this looks a bit wrong at the moment. How can counter possibly equal counter plus 1? This does not mean equality per se. The single equal sign recalls assignment, and it means take the value on the right and copy it to the value on the left, or to the variable, in this case, on the left. So this takes whatever the current value of counter is, 0, adds 1 to it, and then stores that 1 in the counter variable. So now the value is 1. And if you do it again, it goes to 2, goes to 3, goes to 4, and so forth. But honestly, this incrementation technique is so common that there's more shorthand notation for it. You can also just do this. Looks a little weird at first glance, but counter plus equals 1 semicolon does the exact same thing. You can just type fewer keystrokes. And honestly, doing this is so darn common in C that you can even do this. Counter plus plus does the exact same thing by adding 1 to the variable. There's no plus 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 or plus 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 or more pluses. It's only for incrementing individual values by 1. So arguably this version and this version, albeit more verbose, are a little more versatile because you can add 2 or 3 or more at a time. And there are equivalents for you doing decrementation and doing minus minus or the minus symbol more generally in there. All right, so let's actually use this technique in some code. Let me go back into VS Code here. Let me close my File Explorer, and let's go ahead and create maybe this time like a little calculator of sorts. Let me propose that we implement a very baby calculator, or rather not even a calculator yet. Let's just compare some few values. So let me do this. Code of compare.c to create a brand new program called compare. And then in here, I'm going to do a bit of boilerplate. I'm going to go ahead and include CS50.h. I'm going to go ahead and include standard.io.h. And I'm going to go ahead and do int main void. More on that next week. And then inside the curly braces, let's use these new techniques. Let's give myself a variable called x. Just compare some few values. So let me do this. Code of compare.c to create a brand new program called compare. And then in here, I'm going to do a bit of boilerplate. I'm going to go ahead and include CS50.h. I'm going to go ahead and include standard.io.h. And I'm going to go ahead and do int main void. More on that next week. And then inside the curly braces, doing decrementation. Or 3 or more at a time. And there are equivalents for you doing decrementation and doing minus minus or the minus symbol more generally in there. All right, so let's actually use this technique in some code. Let me go back into VS Code here. Let me close my File Explorer, and let's go ahead and create maybe this time like a little calculator of sorts. Let me propose that we implement a very baby calculator, or rather not even a calculator yet. Let's just compare some few values. So let me do this. Code of compare.c to create a brand new program called compare. And then in here, I'm going to do a bit of boilerplate. I'm going to go ahead and include CS50.h. I'm going to go ahead and include standard.io.h. And I'm going to go ahead and do int main void. More on that next week. And then inside the curly, I'm going to include. Let's go ahead and create maybe this time like a little calculator of sorts. Let me propose that we implement a very baby calculator, or rather not even a calculator yet. Let's just compare some few values. So let me do this. Code of compare.c to create a brand new program called compare. And then in here, I'm going to do a bit of boilerplate. I'm going to go ahead and include CS50.h. I'm going to go ahead and include standard.io.h. And I'm going to go ahead and do int main void. More on that next week. And then inside the curly braces, let's use these new techniques. Let's give myself a variable called x and set it equal to the return value of getInt, that other function I promised exists, and let's prompt the user for a value for x with a sentence like what's x question mark, and then a space just to nudge the cursor over. Let's get another variable, y, set it equal to getInt again, and ask the user this time what's y, essentially using the same function twice, but to get two different values. Now, let's go ahead and do something pretty mindless. If x is less than y, go ahead and print out with printf x is less than y, y, another variable, y, set it equal to getInt again, and ask the user this time what's y, essentially using the same function twice, but to get two different values. Now, let's go ahead and do something pretty mindless. If x is less than y, go ahead and print out with printf x is less than y, \n to move the cursor, close quote, semicolon. So it's not that interesting of a program, but it's at least dynamic in that now I'm prompting the user for two numbers. So let's do this. Make compare enter. Seems to have worked. And in fact, I can check that it worked by typing what command to list the files in my directory, ls for short. And now you'll see I've got hello.c, but no hello because I deleted semicolon. So it's not that interesting of a program, but it's at least dynamic in that now I'm prompting the user for two numbers. So let's do this. Make compare enter. Seems to have worked. And in fact, I can check that it worked by typing what command to list the files in my directory, ls for short. And now what command to list the files in my directory, ls for short. And now you'll see I've got hello.c. That this is executable. It's a program you can run. It's not just a simple old file, even though I didn't type it. Seems to have worked. And in fact, I can check that it worked by typing what command to list the files in my directory? ls for short. And now you'll see I've got hello.c, but no hello because I deleted that with rm a few minutes ago. I've got compare.c, which I just created. And then I've also got a program called compare. And the asterisk there is just a visual indicator that this is executable. It's a program you can run. It's not just a simple old file. Even though I didn't type ls previously with hello, it would have similarly had an asterisk next to it in this context. It's a program you can run. It's not just a simple old file. Even though I didn't type ls previously with hello, it would have similarly had an asterisk next to it in this context. But you don't see that in the File Explorer. If I now do compare, well, let's do something silly like 1 for x, 2 for y. OK, x is less than y. Let's do it again. /compare. 2 for x, 1 for y. OK, and I see nothing. Well, why am I seeing nothing? Well, logically, I didn't have a condition for checking for greater than, let alone equal to. So let's enhance this a little bit. Let me compare 2 for x, 1 for y. OK, and I see nothing. Well, why am I seeing nothing? Well, logically, I didn't have a condition for checking for greater than, let alone equal to. So let's enhance this a little bit. Let me go ahead and minimally say, all right, else if x is not less than y, let's go ahead and print out x is not less than y \n, close quote, semicolon. So I'm at least handling that situation too. Let me clear my terminal window, do make compare again, /compare. 1 and 2 works exactly the same. Now let me go ahead and do 2 and 1. There we have better output. Of course, it's not really complete yet, because if I do /compare again and do 1 and 1, it'd be nice to be a little more specific than x is not less than y. It's not wrong, but it's not very precise. So I can add in to the mix what we did earlier. And I can say, OK, well, else if x is greater than y, say x is greater than 2 and 1. Then else, if x is not less than y, let's go ahead and print out x is not less than y \n. Close terminal window, do make compare again, /compare. 1 and 2 works exactly the same. Now let me go ahead and do 2 and 1. There we have better output. Do make compare again, /compare. 1 and 2 works exactly the same. Now let me go ahead and do 2 and 1. There we have better output. Of course, it's not really complete yet, because do 2 /compare. 1 and 2 works exactly the same. Now let me go ahead and do 2 and 1. There we have better output. Of course, it's not really complete yet, because if I do /compare again and do 1 and 1, it'd be nice to be a little more specific than x is not less than y. It's not wrong, but it's not very precise. So I can add in to the mix what we did earlier. And I can say, OK, well, else if x is greater than y, say x is greater than y, else if x equals y, go ahead and print out x is equal to y \n, close quote. But here too, someone observed that this is sort of stupidly inefficient. What line of code should I actually improve here to tighten this up? Yeah?
Instead of else if, you could just get rid of the
Yeah, so line 17, I think I can just get rid of that unnecessary question, because logically that's going to be the case at this point. And now I can go ahead and recompile this with make compare, /compare again, enter. 1 and 1, and now we're back in business, catching all three of those situations, those scenarios there. Questions on any of these things here? All three of those situations, yeah, so line 17, I think I can just get rid of that unnecessary question because logically that's going to be the case at this point. And now I can go ahead and recompile this with make compare, compare again, enter, 1 and 1, and now we're back in business, catching all three of those situations, those scenarios there. Questions on any of these things here? Of those situations, those scenarios there. Questions on any of these things here?
We on 100. We tell you only 100. Kill app. Sure. And you know you're gonna lose. Go! This man slipped. This man slipped. This man slipped. You slipped, man. Bro? Yeah, You hear me? You gonna step on a rock. You sure you wanna go?
Okay. Ready? You're ready. Come on. Get set. Go.
Where you going? What happened? What happened? Answer to me though.
Tight.
From wherever you I'm ready. And oh, this is a parade. Where's the drone at? How did the drone come? Nah, but no. You. Is drone on comms?
Why have I deliberately not done this? Let me rewind just a moment, and let me hide my terminal window just to keep the emphasis on the code here. Why not do this and keep my code arguably simpler? Like, why not just ask 3 questions? Step 9, step 13, and step 17 here. Yeah, what don't you like?
Because then it would check each and every condition, even though, for example, the first one might be fulfilled, it would check the second and third, so that wasted time and computation.
Exactly. It's another example of bad design because now, no matter what, you were asking 3 questions on lines 9, 13, and 17. Even if x ends up being less than y from the get-go, you're still wasting everyone's time by saying, well, is x greater than y? You already might know that it's not. Is x equal to y? You already might know that it's not. And so these 3 conditionals at the moment are mutually exclusive, whereby you're checking all 3 of them no matter what, even though logically that shouldn't be necessary. So our first approach was actually quite better. And in fact, just to show you the density difference here, let me go back to this very first version here, whereby I was only checking that one condition, is x less than y. Well, if you're more of a visual learner, you can actually draw out what code looks like in flowchart form. So here is a drawing of a program that starts here and ideally stops down here. And each of these figures in the middle sort of represent logical components of the code. Here in the diamond here is my Boolean expression, which represents the start of the conditional. So if x is less than y, I have a decision to make, yes or no, true or false. Well, if it is less than y, true, well, let's go ahead and print out, quote unquote, x is less than y, and then stop. However, the first version of that program, recall, just said nothing if it were not the case that x were less than y. That's because false just led to the stop of the program. There's no keyword stop. There's just no code to handle that situation. But the second version of the code, when I actually added an else, looked fundamentally a little different. So now, second version of that code asked, is x less than y? Here's exactly the same. But if it weren't true, it were instead false, that's when I got the message, x is not less than y. But in the third version of the code, where I added the if, else if, then the picture gets a little more complicated. And let me zoom in top to bottom. Here we have a longer flowchart, but the questions are really the same. When I start this program, I ask, is x less than y? If so, I print out, x is less than y. However, in that last version of the program, I was still foolishly asking the same question. Well, wait a minute, is x greater than y? Wait a minute, is x equal to y? And that's the version in which, again, I had all of that unnecessary code, which I just undeleted here, asking 3 questions at a time. Ideally, I don't want to make that mistake by doing it again and again and again. So if I instead revert that code to else if, and else if, then my flowchart looks a little bit different because note and at a time. Ideally, I don't want to make that mistake by doing it again and again and again. So if I instead revert that code to else if, and else if, then my flowchart looks a little bit different because notice the sort of shortcuts now. If x is less than y, true, we do this and we're done, super quick. If x is not less than y, fine, we do ask one more question. X is greater than y? Well, if so, boom, we make our way to the end of the program by just printing that. Only if it's the perverse case where x equals y, do we check this condition? No. This condition? No. This condition, and then OK, now we can print out x is equal to y because it must be logically. Of course, it's been observed multiple times. This is a waste of everyone's time, so we can prune this chart more and just have 1 question, 2 questions, and that alone tightens up the program. So again, if you're more of a visual learner, most any block of code you can translate to this sort of pictorial form, but it really just captures the same logical flow that the indentation and the syntax in the code itself is meant to imply. All right, how about a final exercise with one other type here in the program? Looks again and again and again. So if I instead revert that code to else if, and else if, then my flowchart looks a little bit different because only if it's the perverse case, this must translate both. Before we have a bit of a break, here we have a list of types that we can use, and here we have a list of functions that we can use. Let's go ahead and make a program that's representative of something we do quite often nowadays, but using a different type. So let me go back into VS Code. Let me close compare.c. Let me reopen my terminal window and clear it, just so we have a new prompt. And let's go ahead and create a program called agree.c. It's all too often nowadays that we have code. It's representative of something we do quite often nowadays, but using a different type of code. Let me close compare.c. Let me reopen my terminal window and clear it, just so we have a new prompt. And let's go ahead and create a program called agree.c. It's all too often nowadays that we have to agree to terms and conditions. To be fair, it's usually in the form of a pop-up and a button that we click, but we can do this in code at the command line as well. Let me go ahead and include to start CS50.h and include to start standardIO.h. Let me again, for today's purposes, do int main void, but we'll reveal next week why we keep doing that. And now for a yes/no answer, it suffices just to ask for a single char or character, not a whole string. Do int main void, but we'll reveal next week why we keep doing that. And now for a yes/no answer, it suffices just to ask for a single char or character. And for today's purposes, do int main void, but we'll reveal next week why we keep doing that. And now for a yes/no answer, it suffices just to ask for a single char or character, not a whole string. So let's do this. Char c equals get char, and let's ask the user, quote unquote, do you agree, ? For instance. And now I can actually compare that value for equality with some known answers. For instance, I could say if C equals quote unquote Y, then go ahead and print out, for instance, agreed period backslash n close quote semicolon. Else if C equals n in quotes, let's go ahead and print if equals get char, and let's ask the user, quote unquote, do you agree, question mark, for instance. And now I can actually compare that value for equality with some known answers. For instance, I could say if C equals quote unquote unquote y, then c equals get char, and let's ask the user, quote unquote, do you agree, question mark, for instance. And now I can actually compare that value for equality with some known answers. For instance, I could say if c equals quote unquote y, then go ahead and print out, for instance, agreed period backslash n close quote semicolon. Else if c equals n in quotes, let's go ahead and print out, for instance, not agreed period backslash n semicolon. Now there's still room for improvement here, but notice we're just now using the same building blocks in C in different ways to solve different problems. But notice on lines 8 and 12, I've used single quotes, which I alluded to earlier. Why is that the case? Why single in this case here? Yeah, it's a single character, and this is just the way you do it in C. When you want to compare a single character, you use chars and you use single quotes. When you want to use strings of text, like multiple characters, multiple words, multiple sentences or paragraphs, you use strings. So this would seem to work, but arguably I could be a little more efficient. If the user doesn't type y, I mean, frankly, I could just chop off this else if and make it an else and just assume if you don't give me a y answer, then at least I'm going to assume the worst and you don't agree. But even here, the program's not all that great. Let me go ahead and do make agree, and then do /agree, and do I agree? Sure. I'm going to go ahead and type y. Meanwhile, if I type anything else like n, or sure, at least I'm going to assume the worst and you don't agree. But even here, the program's not all that great. Let me go ahead and do make agree, and then do /agree, and do I agree? Sure. I'm going to go ahead and type y. Meanwhile, if I type anything else like n, or even emphatically no, that would seem to, whoops, why did that not work? Yeah. Exactly. So among the features of CS50, I assume the worst and you don't agree. But even here, the program's not all that great. Let me go ahead and do make agree, and then do /agree, and do I agree? Sure. I'm going to go ahead and type y. Meanwhile, if I type anything else like n, and emphatically no, that would seem to, whoops, why did that not work? Yeah. Exactly. So among the features of CS50's functions, like getChar, is that it will enforce what type of data you're getting. So even though because I used getChar, if the user doesn't cooperate and types in multiple characters, getChar, like some of our other functions, is just designed to prompt them again, and again, until they cooperate. That's useful so that you don't have to deal with that kind of error checking. But here, I could type n in uppercase, and that seems to now work. But that only works because of the else. Let me go ahead and do this, which is very reasonable. I'm going to go ahead and type y, capital Y, which you would hope works. That feels like a bug at this point. Like, it's fine if we don't want to support yes and no. We just want to support y and n. But it's kind of obnoxious not to support the uppercase version thereof. So how can we fix this? Well, let me hide my terminal window, and I could go in and fix this as follows. I could say, well, else if c equals, quote unquote, capital Y in single quotes, and then I could do print out agreed period /n semicolon, and then I can do else. That would work. That would work there. But what rubs you the wrong way, perhaps, about this solution, even if you've never programmed before? Just applying some of the lessons from last week. Yeah. It's redundant. I mean, I didn't technically copy and paste, but like line 14 is identical to line 10, so I might as well have copied and pasted, and that's generally bad practice. Why? Well, if I want to change the English language to say something else in that case, now I have to change it twice, and it's just, I'm repeating myself, which is just bad design. So there are ways.
Oh, you want me to do it?
Yeah.
Okay, I'll try. Doing. Hey, hey. Like that. Are we ready? Huh?
We're heading to town.
Bro, this is about to take longer than the car ride. Why is everybody...
Wait a minute.
My hero could and came back.
Is Colobar, and once in Colobar,
Because when you don't go first,
to address this through other types of operators that we haven't yet seen. If I want to ask two questions at once, that's fine. I can do something like this. Well, if C equals quote unquote Y, or C equals quote unquote capital Y, I can tighten things up using so-called logical operators, whereby I am now closing it from two smaller Boolean expressions. And I care about the answer to one of those questions being true. By capital Y, I can tighten things up using so-called logical operators, whereby I am now taking a Boolean expression and composing it from two smaller Boolean expressions. And I care about the answer to one of those questions being true. So whether it's lowercase y or it makes sense y clauses. Yeah, be lowercase here is in fact correct. All right, well, let's do one final flourish here besides conditionals. We had these now loops. Recall that a loop is just something that does something again and again and again. Here, for instance, to scratch how we might meow 3 times. In C, there's going to be a few different ways to do this. Here is one. You can, in C, declare a variable like I for integer or whatever you want to call it, the number you care about. You can then use repeat block is arguably a while loop. There is no repeat keyword in C, so we can't translate this verbatim. But we could say while I is greater than 0. Why? Because that's sort of logically what I want to do. If I start counting at 3, maybe I can just sort of decrement one at a time and get down to 0, at which point I can stop doing this thing. So I'm going to initialize a variable to I, a variable I to 3, and then I'm going to say while I is greater than 0, go ahead and do the following. And at the end of that loop, before whipping around again, I'm going to use this line of code, which we haven't seen, but you can infer I minus minus just means subtract 1 from I. So this is going to have the effect of starting at 3, going to 2, going to 1, going to 0. And as soon as it goes to 0, this Boolean expression will no longer be true, and so the loop will just implicitly stop, because that's it. So what are we going to put inside of the curly braces besides this decrementation? Well, I think I can get away with just saying meow, and that will now print 1, 2, 3 times. And yet, that's interesting. I sort of counted instinctively 1, 2, 3, even though I'm proposing that we count 3, 2, 1. So can we implement the logic in the other direction, whereby we count up from 0 instead of down from 3? Well, sure. We just have to make a few changes. We can set I equal to 0 initially. We can change our Boolean expression to check that I is less than 3 again, again, and again. And on each iteration of this loop, let's just keep incrementing I with I plus plus. And at this point, it will have the effect of doing 1, 2, 3. 3 is not less than 3, so I won't put any more fingers up. I will meow in total 3 total times. And again, if you're a visual person, here's how we might start counting at 0 initially. Check that I is less than 3, which it is initially. And if so, we print out meow. Then we increment I, and we get whisked around again to the Boolean expression, because that's how while loops work. You constantly have the condition being checked again and again. That's just how C works. As soon as I've incremented I from 0 to 1 to 2 to 3, 3 will eventually not be less than 3, so the answer will be false, so the loop will just stop. So that has the effect of achieving the same. But it turns out that looping some amount of times is so darn common that you don't, so to speak, is another alternative there too, whereby the syntax is a little weird, it's a little harder to memorize, but it allows you to write slightly less code because you write more code on a single line. So the way you read a for loop is exactly the same in spirit. You initialize the variable, everything to the left of this first semicolon. You then check the condition, and the computer does all this for you. If it's I less than 3, if so, you execute what's inside of the curly braces. And then automatically, the thing to the right of the second semicolon happens, so I gets incremented from 0 to 1 in this case. The condition is checked. Is 1 less than 3? It is, so we print meow again, and C increments I to 2. Is 2 less than 3? Yes, so we meow again. I gets incremented to 3. Is 3 less than 3? No. So the for loop stops. So it's exactly the same, but just more magic is happening in this first line of code here, more than you yourselves have to actually write. And it's just arguably more common convention, but both of them are perfectly correct if you'd like to do that yourself. So let's go ahead and actually implement now this. Let me reopen my terminal window and create an actual cat in cat.c. And let's go ahead and do this initially the wrong way. Include standard io.h int main void. And then inside of main, let's go ahead and print out quote unquote meow \n semicolon. And then heck, let me just copy paste. So this is obviously the wrong way, the bad way to do this, because I'm literally copying and pasting. But it is correct. If I want the cat to meow 3 times, I can make this cat. I can do /cat. And I get my meow, meow, meow. But let's now actually use some of those new building blocks whereby we converted Scratch to C. And let me go back into this code, and I'll do the while loop first. So I could instead have done int I equals 3, if we count down initially, while I is greater than 0, then go ahead and print out, quote unquote, meow \n, and then do I plus plus or I minus minus, quote unquote. Could instead have done int I equals 3, if we count down initially, while I is greater than 0, then go ahead and print out, quote unquote, meow \n, and then do I plus plus or I minus minus, quote, meow, I is greater than 0, then go ahead and print out quote unquote, meow \n, and then do I plus plus or I minus minus? I minus minus, because we're starting at 3. Now let me go back to my terminal window and clear it. Do make cat again, /cat, and we get 3 meows, and this is now arguably better implemented. What if I want to flip things around? Well, I could now change, maybe do the normal person. Let me go back to my terminal window and clear it. Do make cat again, /cat, and we get 3 meows, and this is now arguably better implemented. What if I want to flip things around? Well, I could now change, maybe do it the normal person way. I could start counting at 0, and I can do this so long as I is less than 3, and I can do this so long as I increment I on each iteration. Now I can do make cat again, /cat, enter, and that too works. But there's another way I could do this. If I want to count like a normal person, like start counting from 1 and count up 2 and through 3, I could do this, but this is correct. It would iterate 3 times, but it's a little confusing because now I have to think about what it means to be less than 4. OK, that means equal to 3. I could be a little more explicit and say, well, do this while I is less than or equal to 3, using yet another one of those operators. So I can make a cat yet again, ./cat, and that too would work. Now, which of these is correct or best? The convention, truthfully, is in general in code to start counting from 0, start counting up to, but not through the value that you want. So at least you see the starting point and the ending point on the screen, if you will, at the same time. But of course, I can condense all of this a bit more and turn this whole thing into a for loop. And I instead could do for int I equals 0, I less than 3, I plus plus. And then down here, I could do print out, quote unquote, condense all of this a bit more and turn this whole thing into a for loop. And I instead could do for int I equals 0, I less than 3, I plus plus. And then down here, I could do print out, quote unquote, meow. And if only because I typed fewer keystrokes that time, like this feels a little nicer. It's a little tighter and more efficient to create, even though the effect is the same. Indeed, when I make this cat and do ./cat a final time, this here too gives me the 3 meows. So what could go wrong? Well, sometimes you might be inclined to do something forever. And we might have done that in Scratch. And indeed, we did when we had some things bouncing back and forth off of walls and so forth. You can achieve the same thing in code. In fact, in C, we could use a while loop. But there is no forever block. So while suffices. But recall that the while
Come on, man.
Yo.
Bring her. Bring her.
while loop expects a Boolean expression. And if I want to do something forever, I essentially need an expression here that's always true. So I could do something stupid and arbitrary, like while 2 is greater than 3, or while 1 is less than 2. I mean, make a statement of fact that never changes, ergo, it's just going to run forever. But if the whole goal here is to do something forever and to get this Boolean expression to be true, the convention in programming is just to literally say while true. And that implies and functionally means that you will do this thing forever unless you somehow prematurely break out of those curly braces. More on that before long. So if I want to meow forever, I could now just do this. And this would be an infinite deliberate loop. But unlike a game where you might want it to keep going and going and going for some time, I'm not sure this is going to be the best thing for us. Let's go ahead and try this. So let me go ahead here and include for good measure CS50's library, if only because it too is giving us features like bools. Here I'm going to go ahead and say while true. And then inside of my curly braces, I'm just going to print out meow. Let's go ahead, \n, semicolon. Let's go ahead here and make cat one final time. Let me go ahead here and do ./cat. And this is like the annoying cat game, cat. And this is like the annoying cat game, just like meowing, meowing, meowing endlessly. Like I've now kind of lost control over my terminal window. And mark my words, at some point you might do this too. But let's go ahead and take a juicy 10-minute break here. Game cat. And this is like the annoying cat game, just like while true. And then inside of my curly braces, I'm just going to print out meow. Let's go ahead, \n, semicolon. Let's go ahead here and make cat one final time. Let me go ahead here and do ./cat. And This is like the annoying cat game, just like meowing, meowing, meowing endlessly. Like I've now kind of lost control over my terminal window. And mark my words, at some point you might do this too. But let's go ahead and take a juicy 10-minute break here. We have some delicious blueberry muffins out in the transept. Come back in 10, and we'll figure out how to stop this here cat. All right, so it's been about 10 minutes, and like VS Code is freaking out with high code space CPU utilization detected. Consider stopping some processes for the best experience. So this is what happens when you have, intentionally or otherwise, an infinite loop, insofar as I've been printing out meow endlessly. And I was warned by my colleague that I probably shouldn't let this run too long because we might lose control over the environment altogether. But the answer to how to solve this is going to be Control-C. So there's a few cryptic keystrokes that you can use to generally interrupt things, as in this way. And in fact, if I go back, and you'll see, yeah, I kind of lost control over my code space here. I'm going to go ahead and try to reload the window altogether. But had I hit Control-C in time, let's hope this doesn't now go off the rails. Control-C would have been our friend. There we go, and we're back. Okay, so now that we've got control over our so-called code space again, how can we go about making our meowing program a little more dynamic? Insofar as let's start asking the user how many times they want the cat to meow, certainly rather than do it an infinite number of times, and even rather than do it 3 times alone. I think we have all of these building blocks thus far, so let me go ahead and stay in cat.c here and go ahead and delete the body of the contents of my main function. Let's go ahead and do this. Let's give myself an int, and I'll go ahead and call it n for number, though I could be more verbose than that if I wanted. I'm going to set it equal to the so-called return value of getInt, which we're calling is going to get an integer from the user, and quote unquote, let's ask the user, what's n? Just like I asked earlier, what's x and what's y, where n is the number of times I want the cat to meow. Now, how can I use this variable? Well, we have that building block too. I could use a while loop or a for loop. And if I use a for loop, I could do this. I could initialize a variable I for integer, set it equal to 0 initially. I could then do I less than, not 3 this time, but n, so I can use that variable as a placeholder inside of the loop to indicate that I want to do this n times instead of 3. And on each iteration through this loop, I can do I++. Of course, I could be counting down if I prefer by using decrementation, but logically, I would say this is canonical. Start at 0 and go up 2, but not through the value that you actually care about. And I'll go ahead now and print out, quote unquote, meow with a \n, semicolon, back down to my terminal, make this cat again, /cat enter. I'm prompted this time for n. I can still give it 3, and I'm going to get 3 meows this time. However, if I run it again with /cat and a different input like 4, of course, I'm going to get 4 meows instead. Now, what is getInt doing for me? Well, it does a few things similar to getChar doing a few things for me. For instance, suppose that instead of answering this question correctly with a number, n, I say something random like dog. That is not an integer, and so the getInt function is designed to reject the user's input implicitly and just reprompt again, again, and again. I can try bird, and it's going to do this again. So somewhere in the implementation of getInt, there's a loop that we wrote that does this kind of error checking for you. But it doesn't do everything, because an integer is a fairly broad category of numbers. It's like -infinity through +infinity, and that's a lot of possibilities. But suppose
Why is the right lane moving faster than the... Yo! Go! Bro, like the whole city out the balls out here. Bro, every... What the... What kind of car horn is that? Bro, I never heard an ice cream truck that sound like that. Oh, what the hell?
I don't want some of those possibilities. Suppose that it makes no sense to ask the cat to meow like -1 time, and yet the program accepts that. It doesn't do anything or anything wrong, but I feel like a better designed program would say, no, 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 like -1 makes no sense. Let's meow 0 or 1 or 2 or more times instead. So how can I begin to add some of my own error checking and coerce the user to give me the type of input I want? Well, let me clear my terminal window and go back up into my code. And why don't I do something like this? After getting n, let's just check if n is less than 0, because if so, I want to prompt the user again. And I can prompt the user again by doing n equals getInt, quote unquote, what's n, question mark, semicolon. Now, what's going on here? Well, on my user again by doing n equals getInt, quote unquote, what's n, question mark, semicolon. Now, what's going on here? Well, on line 6, I'm doing two things. I'm getting n. I'm the program accepts that. It doesn't do anything or anything wrong, but I feel like a better designed program would say, no, 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 like -1 makes no sense. Let's meow 0 or 1 or 2 or more times instead. So how can I begin to add some of my own error checking and coerce the user to give me the type of input I want? Well, let me clear my terminal window and go back up into my code. And why don't I do something like this? After getting n, let's just check if n is less than 0, because if so, I want to prompt the user again. And I can prompt the user again by doing n equals getInt, quote unquote, what's n, question mark, semicolon. Now, what's going on here? Well, on line 6, I'm doing two things. I'm getting an integer from the user, and I'm not only storing it in the variable n, I'm also technically creating the variable n. So I didn't call this out earlier, but on line 6, when you specify the type of a variable and the name of the variable, you are creating the variable somewhere in the computer's memory. And that's necessary in C to specify the type. If the variable already exists, though, and you just want to reuse it and change it later on, it suffices, as in line 9, just to reference it by name. It would be sort of stupid to specify the type again, because C already knows what type it is, because you told C what it is on line 6. So that's why line 6 and 9 are a little bit different. So let's see how this now works. Let me go back to my terminal window and remake this cat. Let me do /cat again. Let me not cooperate and type in like -1 again. And notice I am reprompted this time. Fine, fine, fine. Let's type in 3. And now it works. But you can perhaps logically see where this is going. Let me go ahead and run this again, /cat, type in -1, type in -1, and it didn't prompt me again. But that's consistent with the code. If I hide my terminal window here, you'll notice that I've got 1, maybe 2 tries to get this question right. And after that, there's no more prompting of me. Now, you can kind of imagine that this is probably not the best way to do this if I were to go inside of line 9 and then move the cursor down and say, OK, well, if n still is less than 0, well, let's just do getInt again and ask what's n question mark. And heck, OK, if it's still less than 0, well, let's just keep asking the same. Right? Why is this bad? I'm repeating myself. I'm essentially copying and pasting, even though I'm retyping. I mean, this just never ends, right? Like, how many chances are you going to give the user? In spirit, you'd hope that they don't not cooperate this many times. But really, to do this the right way, we should probably prompt them potentially as many times as it takes to get the correct input. So this is not the right path for us to be going down. But of course, we have already now this notion of like a loop, whereby we could just do this in a loop, ask the question once, and maybe just repeat the question again, but the same question. So how might I do this? Well, let me go ahead and delete all of this. And let me just try to spell this out logically. So I want to get a variable n from the user. And let's go ahead as follows. While true, I know how to do infinite loops now. And even though that created a problem for me with the cat, I bet we can sort of terminate the loop prematurely like I proposed earlier as follows. I could do this. Int n equals getInt and ask the user again, what's n question mark. And then I could do something like this. If n is less than 0, well, then you know what? Go ahead and just continue on with the same loop. Else, if it is not the case that n is less than 0, what do I want to do? I want to break out of n. I bet we can sort of terminate the loop prematurely like I proposed earlier as follows. I could do this. Int n equals getInt and ask the user again, what's n question mark. And then I could do something something like this. If n is less than 0, well, then you know what? Go ahead and just continue on with the same loop. Else, if it is not the case that n is less than 0, what do I want to do? I want to break out of this loop. So this is new syntax. This is something you can do in C, whereby if n is less than 0, well, then you know what? Go ahead and just continue on with the same loop. Else, if it is not the case that n is less than 0, what do I want to do? I want to break out of this loop. So this is new syntax. This is something you can do in C. Do I continue on with the same loop? Else, if it is not the case that n is less than 0, what do I want to do? I want to break out of this loop. So this is new syntax. This is something you can do in C, whereby if n is less than 0, fine. Continue means go back to the start of the loop and do the same exact thing again. Otherwise, if you instead say break, it means break out of the loop and go to below whatever curly brace is associated with that loop. So continue essentially brings you to the top, break brings you to the bottom, if you will. So logically, I think this is so go to below. Otherwise, if you instead say break, it means break out of the loop and just continue on with the same loop. Else, if it is not the case that n is less than 0, what do I want to do? I want to break out of this loop. So this is new syntax. This is something you can do in C, whereby if n is less than 0, fine. Continue means go back to the start of the loop and do the same exact thing again. Otherwise, if you instead say break, it means break out of the loop and go to below whatever curly brace is associated with that loop. So continue essentially brings you to the top, break brings you to the bottom, if you will. So logically, I think this is right, but this code curiously isn't quite going to work and get me a value for n. Let me go ahead and open my terminal window again. Let's make this cat, and cat.c, line 19, character 25 is an error, use of undeclared identifier n. Well, what does that mean? Again, cat.c, line 19. Let me hide my terminal window, highlight line 19. N is being used in line 19, but I created it in line 8, and so what's the problem? Why is it not declared, seemingly? Yeah? Yeah, this is a subtlety, but I'm creating n inside of this loop. I mean, literally between the curly braces on line 7 and 17. The implication of which, because of how C works, is that that variable only exists inside of that for loop. This is a problem of what's known as scope. The variable n only exists inside of the scope of the while loop in which it was declared. So how do I actually fix this? Well, I need to logically somehow declare that variable n outside of the loop so that it exists later on in the program as well. And there's a few different ways I can fix this, but the best way is probably to move the declaration of n, so to speak, the creation of n outside of the curly braces, and maybe kind of squeeze it in here below line 5, so still inside of main, whatever that is, more on that next week, but in the same curly braces as everything else. So I can in fact do this, and this is where the syntax gets a little bit different. I can solve this quite simply as follows. I can go down to a new line 6 and just say int n semicolon, and that's it. This declares a variable called n. It creates a variable called n. It initially doesn't give it any value, so who knows what's in there. More on that another time. But now on line 9, I don't need to recreate it. I just need to assign it a value. And because now n has been declared on line 6 and between the curly braces on line 5 and all the way down on 24, now n is in scope, so to speak, for the entirety of this code that I've written. So let me reopen my terminal window and clear that old error. Let me do make cat again. Now the error messages is gone. Let me go ahead and do /cat. What's n? Now I'm back in business, and I can do 3 for meow, meow, meow. But better yet, because I'm inside of a loop now, watch that I can do -1, -1, -1, -1, -2, -3, -50. Finally, I can cooperate with something like 3. And because I'm in a loop that by design may very well go infinitely many times until the user actually cooperates and lets me break out of that exact loop. Now, I, strictly speaking, don't need both continue and break. I wanted to demonstrate that both exist, but this is like twice as much code than I actually need. If logically, I just want to break out of this loop if and only if n is greater than or equal to 0, because I'm sort of comfortable with the idea of 0 meows, but negative makes no sense, well, I can just flip the logic. I can say if n is greater than or equal to 0, then go ahead and break, and I've tightened up the code further. I could technically do something else. I could say something like if n is less than 0, but wait a minute, I want to negate that. You can start to do tricks like this, an exclamation point with some additional parentheses so you can invert the logic. It's arguably a little hard to read, even though that would be logically correct. So I'm just going to say more explicitly as before, if n is greater than or equal to 0, break out of this here loop. All right, so this is one way to use an infinite loop, but it turns out there's another construct that you can do altogether that is a feature of C. Instead of using a while loop and forcing it to be infinite by using while true and then eventually manually breaking out of it, there exists another type of loop altogether, and that's called a do-while loop. And you can literally say the word do, which means do the following, then you can do exactly what we did before, n equals get int, quote unquote, what's n question mark. So exactly like before, but then after those curly braces, you use a while keyword, so at the end of the loop instead of the beginning, and that's where you put your Boolean expression. I want to do all of that while n is less than 0. So you can kind of invert the logic and now kind of tighten things up further by just telling the computer, do the following. What's the following? Everything in between those curly braces, while n is less than 0. And this implicitly handles all of the continuation and all of the breaking by just doing what you've said. Do this while this is true. But the difference between this do-while loop and a normal while loop is literally that the condition is checked at the bottom instead of the top. So when you say while parentheses something, that question is asked first, and then you proceed maybe. This condition is only asked at the very end. And why is this useful? Well, oftentimes when writing programs where you want to do something at least once, like you obviously want to ask the user this question at least once, there's no point in asking a question like while true or while anything else. You should just do it. And then you should do it again if the expression evaluates to true and tells you to do something. Now, you haven't played with these loops yet, most likely, unless you have programmed before. There's a fun sort of meme that's apropos of this moment. So let's see if this maybe causes a few chuckles. If you remember Looney Tunes here. This is funny for people in the know. There we go. Thank you. OK, if this doesn't make sense, it eventually will, and it still might not be funny, but it will at least make sense. And it illustrates the difference between do-while loop, like the roadrunner is stopping because he's checking the condition. While not on edge, he'll run. But if he is on the edge, he's not going to proceed further. But of course, the coyote here, he's going to do running no matter what, and then only too late does he check. Haha, he's still on the edge. All right. So, thank you. All right. Now you're cool. All right. So many more memes will now make sense as a result. But let's go ahead and revisit this code and maybe do something a little bit different here, whereby we no longer want to just futz around with some of these conditionals and these loops. Let's actually make the software a little better designed. And to do this, we'll revisit an idea that we touched on last week to do with problem set 0, which was like create your own function. Like C does not come with everything you might want. CS50 library is not going to come with everything you might want. And at the end of the
been doing on how to God do these things for a reason. I'm not gonna lie, bro. I'm gonna tell y'all at the end of the stream.
Today, a lot of programming is about abstracting away your ideas so you solve a problem once and then reuse it, reuse it, reuse it. And heck, you can package it up in a so-called library like we have and let other people use it as well. So here, for instance, in Scratch is how we could have implemented the notion of meowing as by getting the cat to play the sound meow until done. We abstracted it away, and then we had a magical new puzzle piece called meow. In C, this is going to be a little weird today, but next week these details will start to make more sense. You would instead do the following. Literally type void, the name of the function you want to create, and then void again in parentheses. For now, know that this is the return value of the function, so void means it returns nothing. This is the input to, or the arguments to the function. Void means it takes no inputs. And that makes sense because literally meow doesn't return anything. It doesn't take anything. It just meows. It has a so-called side effect, audibly last week. So this means, hey C, invent a function called meow that takes no input, produces no output, but does have a side effect of printing meow on the screen. Meanwhile, if I wanted to do something like this in code last week, where I meowed 3 times, well, it's fine. We have the building blocks for this. And here's where inventing your own function starts to get more compelling. I can abstract away the notion of meowing now. Like this doesn't come with C. It doesn't come with the CS50 library. I just created in the previous code this meow function. So I can encode with a for loop and that new function meow 3 times. But I can abstract this away further. Recall that the refinement in Scratch last time was this. I could edit the new function, and I can say it actually does take an input, otherwise known as an argument, called n. And I clarified that this means to meow some number of times. And then inside of those scratch blocks, I repeated n times the meowing act. Well, in C, I can achieve the exact same thing, even though it's going to look a little more cryptic, but meow still returns nothing. It has an audible or visual side effect, but it doesn't return a value. But this version does take an input. And this might look a little weird, but just like before, when you create a variable in C, you specify the type and the name. When you invent your own function in C, and it takes one or more inputs, aka arguments, you specify the type and the name of those as well. No semicolons up there, just inside of the parentheses. And you get used to with practice this convention. But the rest of this code is exactly the same, except instead of 3, I'm now using n. So again, I'm just composing the exact same ideas as last week, even though it looks way more cryptic this week, but it will become more and more familiar with more and more practice. So how can I go about implementing this myself? Well, let me propose that we do something like this. Let me go back to VS Code here, and let me go ahead and let's really delete most of the code that I've written inside of main, and let me just suppose for the moment that meowing exists. And I'm going to go ahead and say, for the first version, for int I equals 0, I less than 3, so we're not going to take input yet, I plus plus, and then I'm going to go ahead here and say, meow is what I want this function to do. Now, if I scroll back up, you'll see there's no definition of meow yet, so I'm going to invent that too. I'm going to go up here and say void, meow, void, and again, this first version means no input, no output, just slash n. Do make cat. So far, so good, dot slash cat, we're back in business, but I've abstracted the function away. Now, much like last week where I sort of dramatically dragged the meow definition way down to the bottom of the screen just to make the point that you don't need to see it anymore, out of sight, out of mind, let me sort of try to do the same here. Let me highlight and delete that, and like go way, way, way down arbitrarily, just to be dramatic, and paste it near like 100th line of code and scroll back up. Now, out of sight, out of mind, I've already implemented the idea of meowing, we don't need to see or talk about it again. But there is a caveat in C. When I now clear my terminal and make this cat, now I've introduced a problem. And there's like more problems it seems than code. Let me scroll back up to the first such error, and you'll see this. On line 9 of cat.c, character 9, there's an error. Call to undeclared function meow and then something fairly arcane. But that means that meow is no longer recognized as an actual function. I know that it doesn't come from CS50.h, and I know it doesn't come from standard.io.h. It's just down there. But why is the compiler being kind of dumb here? Yeah, because because insofar as the first version worked, like logically, it would seem that putting it at the bottom was just a bad idea, because C compilers are fairly, like they won't proactively do you the favor of like checking all the way down at the bottom of the file. They're going to take you literally. So if meow doesn't exist as of line 9, that's on you. Like that is an error. So I could fix this by just undoing what I did and move it way back up to the top. But let me argue that in general, when writing C programs, the main function, which I keep using and we'll talk more about next week, is literally meant to be the main part of your code. And so it kind of stands to reason that it should be at the top, because when you open the file, it'd be nice to see the main program that you care about, the main function. So there's an argument to be made that it's a little annoying to have to put my functions all at the top, which is just going to push main further and further down. So there is a solution. And this is, dare say, the only time copying and pasting is appropriate. Let me delete most of these blank lines, which is unnecessarily dramatic, and just move it below main, as over here. The way I can, the solution here, though, is to do this, to copy the first line of the main function, its so-called signature, and then just put that one line and only that one line with a semicolon above main. And this is what's known as a prototype. So a prototype is just a bit of a hint to the compiler, a promise, if you will, that, hey, compiler, there will exist a function called meow, it takes no input, and it returns no output, semicolon. And it's on the honor system that it will eventually exist later in the file. We'll talk more about this next week, why that works, but this is sort of a promise to the compiler that it will eventually be defined. Now, what I've done here on line 4 as an aside is what's generally known as a comment. I just wanted to put on the screen exactly what I was verbalizing. Anything in C that starts with / is a note to self, like a sticky note in Scratch, which is just for the human, not for the computer, and it's a way of reminding yourself or someone else what's going on that line or those lines of code. But I'll go ahead and delete it for now. It's unnecessary, because now if I go back into my terminal and clear those errors, make this cat again, now it does work, because the meow function has been defined exactly where it should be. And now I can make the new version of this cat even better. I could change the function meow to take a variable n as input for the number of times, and then in here I could do something like my for loop, for int I equals 0, I less than n, I plus plus, and then in this for loop I can print out quote unquote meow, and then I'm going to have to change this too, because I have to copy and repaste it, if you will, or just manually fix that. But now I can get rid of all of this and do meow 3, for instance, and this now will be the second version of the Scratch code, if you will. Make cat, still going to work exactly the same, meow, meow, meow. But now I've implemented my own function that does take input, even though it doesn't happen to return any output. All right, questions on any of these examples just yet? Confusion? Input, but actually here, it'd be nice to and then reuse scope. Means, again, meow takes no inputs. Let me go ahead now and rerun make cat. And there we have an undeclared identity that you create. And so the solution is I have to change a number of time of on passing it into a map. This is even more point here is just this matter of scope. All right, so let's take a higher level look now at some of the things we've been thinking about, and then we'll do a final deep dive or two on some of the some of the problems that we can solve with all of these building blocks and some of the problems that we're sort of ignoring for now. So when it comes to writing good code, code, CS50, and really the world in general, tends to focus on these kinds of axes: correctness, design, and style. What does this mean? Correctness just means, does the code work the way it's supposed to? In the context of a class, it should do exactly what the homework.
Chat, bro, for real. It's absurd. Man, how far are we, bro?
Homework assignment, aka problem set, tells you to do. In the real world, it should do exactly what someone decided the software should do: the product manager, the CEO, or the like. Correctness just means it behaves as it should. That's different, though, from how well designed the code might be. And we've seen that a few times. I've had some simplistic examples in Scratch and C that were 100% correct. Like, it did the right thing logically, but I was wasting the computer's time, I was wasting the human's time by asking more Boolean expressions than I needed to, and so forth. So design is more about, like in the world of English, like not only saying things that are correct, but doing it well, like in making a good cogent argument, not just one that happens to be correct. Style, meanwhile, is the third axis on which we might evaluate the quality of someone's code, and that's more of the aesthetics. Like, is everything pretty printed? That is, nicely indented? Are variables well named and not just called XYZ arbitrarily or something like that? So style matters really to other humans, not to the computer, but to other humans. And to illustrate these, you'll see that in problem set 1 onward, you'll be given a number of tools that you can use. So one of those tools is called Check50. And in each problem set, problem in C and Python and other languages, you'll be showed how you can test your own code. And you can literally run a command that CS50 created called Check50. You'll then specify what's called a slug, which just means a unique identifier for that homework problem. And you'll get quick feedback on whether or not your code is correct. It doesn't mean it's well implemented or well designed or pretty, that is well stylized, but at least that's the first gauntlet in getting good code submitted. Design, though, is much more subjective. Design is something you get feedback on from a human, for instance, in section or a teaching assistant, or in software. You can actually see atop VS Code, there's a couple of buttons that I haven't yet used but could. Design 50 is built on top of the CS50 duck, whereby if you have a program open in a tab, you click Design 50, you will get ChatGPT-like advice on how you can improve, not the correctness of that code, but the design of that code, the quality thereof, which is a bit more subjective and modeled after what a good teaching assistant might say. Style 50, meanwhile, is a third tool that will provide you with feedback on the style of your code. And it will show you on the left what your code looks like, and on the right what your code really should look like, insofar as it should be consistent with what we've taught in class and consistent with CS50's so-called style guide. And those of you who have some prior programming experience undoubtedly won't like some of CS50's stylistic choices, and that's going to be the case in the real world too. But as I alluded to earlier, in typical companies, you would have an official style guide or tool to which everyone adheres so that everyone's code actually looks the same as everyone else's, even though people have contributed different solutions to problems. So correctness, design, style is not only how we, but really the world writ large tends to evaluate the quality of code, and we do it by way of these CS50 specific tools here. All right, how about one final flourish then to this here program? Back in VS Code, I've got a correct solution right now. It's well styled, I'll stipulate, even though it could stand to have some more comments. So for instance, I could do something like this, like meow some number of times, a comment to myself. Or up here, I could say something like get a number from user, just to remind myself and my TA or my colleague what it is this code is doing. But what more can I do in the way of design? Well, this function here, getInt, will indeed get me an integer, but not just positive or 0, but negative. And I could go in and add a bunch of code like before, like I could actually do, instead of this line, I could do something like int n semicolon do the following, or n equals getInt, and then I can say what's n question mark, and then after that I can do something like while n is less than 0, keep doing that. So I can have a pretty verbose implementation of getting user input, or I can implement another function of my own that only gets a positive integer or non-negative integer from the user. For instance, I might do something like this. I could declare at the bottom, maybe below my main function, a function like this. Int, how about get n, and then inside
This kid.
of this, I might say void because I'm not going to pass in any inputs. Then inside of this function is where I'm going to do int n, do while n equals get int, quote unquote, what's n question mark. And then down here I'm going to do while n is less than 0. But rather than do something immediately with n, because I'm no longer inside of my so-called main function, what I'm going to do, which is new, is return this value n. And notice that this notion of returning a value, which is the first time I've done this explicitly, is consistent with this little hint here on line 19, which implies that this get n function, which I'm inventing, is going to return not void, which means nothing, but an integer. And that's the whole purpose of this function in life now. If I scroll back down here, I can get rid of this whole block of code and just say get n from the user, and then I can immediately call meow with that value. I need to do one other thing. I need to highlight this line of code here, and I'm going to go ahead and add another prototype up top, which is the only time again for now that copy paste is encouraged and best to do. So I've invented my own function get n. The whole point being now I have this sort of abstraction here of a function whose whole sole purpose in life is to get me not just an integer, but one that is 0 or positive and not negative. If I open my terminal window, clear the mess from before, make this cat, /cat, what's n3, I'm now back in business. And again, we've essentially translated from scratch last time into C this time exactly how we might modularize now the code, abstract away these lower level details, and ultimately create my own function that, as before, takes not only arguments, but in this case has not only side effects, or doesn't have side effects, but rather a return value this time. All right, so as you walked in, we had a little walkthrough of Super Mario Brothers playing from yesteryear, which was a side-scrolling game in which Mario would jump down and go up, down, left, right, and try to collect coins and make it to the end of the level. There's a lot of obstacles throughout this kind of game, whereby the world might look a little something like this. Like there's a pit that Mario's got to jump over, and then there's these coins hidden typically behind these question marks that he can jump up and hit his head with and actually accrue points. Now, we're not going to do anything graphical just yet. We're leaving graphics behind for now in the form of Scratch, but with C, we can implement some of these ideas. For instance, arc blocks to start implementing to generate just this row of 4 question marks. I dare say there's a bunch of ways we can do this. In other words, let's see if we can't use all of today's building blocks to start implementing our own tiny version of Super Mario Brothers in a file, say, called mario.c. So let me open and clear my terminal window. Let me run code mario.c. And let's just try to do something super simple like print 4 question marks in a row. Well, to do this, I need printf, so I'm going to include standard io.h. I'm then going to do int main void. More on that next time. And inside of main, my default function that just automatically, as before, gets called for me, I'm going to print out the simplest possible implementation, just print out 4 question marks like that. So no need per se for a loop just yet, but I think we can go down that rabbit hole too. Let me go down into my terminal window, make this version of Mario, /Mario, enter, and voila. We have a very black and white version, textual version of 4 question marks in the sky. Now I'm kind of cheating here by just hard coding 4 question marks. What if I wanted not 4, but 3 or 5 or some other number? Well, we could do that with a loop too. So let me change this code here and do something like this. For int I equals, say, 0, I less than, say, 4 for now, I++. Then inside of this loop, I can print out 1 question mark at a time, semicolon. Now let me go back to the bottom, make this version of Mario, /Mario, enter, and voila, it's not actually correct this time. So why am I getting a column instead of a row with this here change? Yeah? Yeah, so I've